Hello everyone, so in this video let's talk about the Di-P-Methane reaction. This is one of the fascinating radical reactions we encounter in photochemistry. Now we have talked about a lot in photochemistry throughout this playlist. So I will put the link here. You can go to our playlist and see whether is there any particular videos that you might be interested in, right? Now let's look at the mechanism. So I will take an example. So this is my molecule which I have been selected. During this reaction we have two products, right? So I'm going to explain to you how each products are gonna form based on our mechanism. Now the first step would be the formation of the biradicals, right? So here you have two pi bonds, right? So these two pi bonds are the positions where the reaction starts. As the first step, we have the formation of two radicals and a new bond. So one of the electrons here will go here to form a bond between this carbon and this carbon. So one electron is going here, the other electron is coming from this particular bond. So you know this one bond has two electrons, right? So one electron is going to here and the other electron is coming to here to form the radical. Now the same happens here, right? So one electron is going here to form the bond and the other electron comes here to form the radical. Now we have the product. It's like this. Here we have the R1 and here we have the R2. Now we have a new bond formed between these two carbons and we have two radicals here. And the next step, right? Next step, look at these two bonds. This is the number 1 bond and this is the number 2. These two sigma bonds. So our two products, right? Our two products will based on the breakage of either of this bond. One product will come from the breakage of this bond and the other product will come from the breakage of this bond. So at first let's go through the first bond, right? So let's break this first bond and see what kind of product would we have. Now in this case what happens is this bond will break and one electron will come here and it will join with this particular electron to form a pi bond between this carbon and this carbon, and the other electron will go here to form the radical. Now we have the product. It's like this. So here we have the R2 and here we have the R1. So this bond is not there, this bond is not there. We have this bond, okay, and we have a pi bond between these two carbons. Now we have a radical, so let me draw it correctly. Yeah, there must be another bond between here. Okay, here we have the R1 and here we have the radical and we have another radical here, right? So the last step would be the formation of another bond between this carbon and this carbon by these two radicals. These two radicals are coming together to form a new bond, which is like this. Here we have a bond like here and the other bond is going through here. We have pi bond here. So this is the product A. So let me label it as A, capital A. This is the product A. And the product B, right? The product B is resulting from the breakage of this second bond. So let me take yellow color for it, right? So I'm going to draw the mechanism for the second product through yellow color. Now the same thing happened in here too, right? So let me erase these guys. Now what happens is this, just like the same, this bond will break, right? This bond will break. So a new pi bond will appear between these two carbons. This one and this one will form a new pi bond and other electron will go here to form the radical. Now we have the product. It's like this. So here we have the R2 and here we have the R1. So this bond is not there now, it has been broken and we have a bond here between these two and we have a new pi bond. And also we have two radicals, one is here and the other one is here. And the last step would be the formation of the other bond between these two positions. So these two radicals comes together, right? So now here we have the final structure. It's like this. We have the pi bond here and we have a new bond between these two carbons. So this is our structure B. This is our product B. So if you look carefully, this A and B, these two are not equal, right? These two are not equal, because like as you can see here, we have the pi bond adjacent to the R2 group, but here the pi bond is adjacent to the R1 group. So these two structures A and B, these are not equal. That's very important. Now if we have a certain situation, right? So these are the two products that can be formed through this reaction mechanism, right? So let's say if certain cases we have only this A product or B product. So in those cases, how we can exactly say which product forms? So the formation of either of these products we are based on the strength of these two bonds. Let's say this first bond, right? This first bond is more stronger compared to the second one. So in that case, the second bond is the one who tend to breaks. So through the second bond, right? So the breakage of the second bond, you have the mechanism through this. So you have the product B. But if you have stronger bond as the second bond, right? So compared to the first bond, the second bond is much more stronger. So in that case, the first bond will be the one which is going to be break. So when the first bond is breaking away, right? So when it's going to break, when it's going to be the one who's going to break, we have the mechanism going through this direction. So we have the product A. So the strength, right? So these two bonds strength, those are the very sensitive factor for this reaction mechanism. So the strength can be vary based on the substitution, right? So these R groups or other groups may attach to these points. These things can alter the strength of these two bonds. So based on the situation, based on the molecule, based on the compound, the product ratios would be different. So in this case, you can say that mostly, right? Mostly these two bonds are the strength wise, right? I'm talking about the strength wise. Based on the strength, these two bonds are same. So we would have the 50% ratio, right? 50% of this and 50% of this. Likewise, mostly, right? Mostly, it can be varied. But if you have a different substitute, right? Different components attached to your compound, right? So in that case, you have to be very carefully and observe which bond is stronger. So that stronger bond will not be broke. So other bond, it will broken, and the reaction mechanism would follow through that particular path. And there's another small thing which you need to remember, that this reaction happens through only the singlet state, right? Singlet excited state. That this reaction won't happen through the triplet excited state, right? So that's very important. So this whole reaction, these whole two products are forming through the singlet excited state. So I hope you know now this is going to be a pi to pi star transition, right? There are no oxygen atoms in there, so there are no lone pairs. So it's definitely not the N to pi star. There are only pi bonds, so it's definitely the pi to pi star transition. I hope you remember now that there are two transition states: singlet transition state, a singlet excited state, and the triplet excited state. So that's what I have mentioned here. So this particular reaction mechanism only happens through the singlet excited state, not through the triplet excited state. Let's say you have your compound excited to the triplet excited state, right? So here I'm going to draw it again. Now here we have the same structure. So in this case you have the triplet excited state, right? Triplet pi to pi star transition. Now what happens? Now this particular reaction won't happen, only the isomerization. So isomerization, this will happen. So in this case what happens is the positions of these R2 groups will differ. sorry, let me draw it again. These two are in inwards like this.